In this class, I will explain about one of the important tests which is called as chi-square test, denoted like this. So this test is used to accept or reject the observed and expected values in an experiment. So let us say you have two sets of data. One is observed value from the experiment, another is expected value from the theoretical considerations. So normally in any modeling project or modeling problem, we will be getting observed values from the experiments, and based on some equations, some theory, so we can always compute the expected values. So if you have two sets, that is one set of observed values and the second corresponding values of expected values, if you can have a comparison between those two, one thing we have learned, the coefficient of correlation, which we have computed earlier, that is one of the measures. Another thing is, in statistics, we are going to examine whether those two sets of data, they are compatible or any difference is there in the set of data, like that, using one of the tests called chi-square test. So this chi-square test almost it depends on the percentage of significant level. So how much percentage we are relying on the significance of the estimated values, that's what we are going to find out. So further, the reference is, you have a table, chi-square values table in the statistical tables, so that you have to refer, so for the analysis of chi-square test. So normally we take 5% significance level or 10% significance level for analyzing the data. Now the formula to find out this chi-square, which is called as a statistic. So the formula is like this: sigma I is equal to 1 to n, where n is the number of observations, total number of observations, OI minus EI whole square by EI. So where OI is the observed data, EI is the expected data or estimated data. Expected or estimated, you can call it as estimated also. The estimated data you can get from the theoretical equations or distributions, like normal or binomial or Poisson distribution, like that. So this is the formula. So we are going to use that to find out this chi-square, which is a statistic, which we can apply for a set of given data. Suppose after calculating this, if chi-square calculated is less than chi-square tabulated, or you can take equal to also, then we can say that the observation is observed data and expected data don't differ much. That means we accept the null hypothesis. Null hypothesis means almost both observed data and expected data are almost same. So there is not much difference. That is the meaning of null hypothesis. Suppose if this chi-square calculated value is greater than chi-square tabulated value from the tables, then we are going to reject the null hypothesis. To accept the null hypothesis, or in other words, to agree with that the observed and estimated values, they won't differ much. So this value, chi-square calculated value in this formula, should be less than chi-square tabulated value, which you can get directly from the table. So this is how we can judge whether the observed and estimated values for a particular experiment we can rely on, whether we can rely on this observed data or not, based on the theoretical consideration of estimated values. Now I have taken an example here. So these are the observed values. There are 6 observed values: 103, 143, 98, 42, 8 and 6. The corresponding estimated or expected values are 106, 141, 93, 41, 14, 5. So these estimated values, they are obtained from distributions, theoretical distributions. So sometimes they will give the values directly. So we can always get these values from the normal distribution. So in this problem, both the values are given. Now the question is, check the test, that is chi-square test at 5% significance level. That means if you can, how much you can relay. Suppose if your level of confidence is 5%, can this test be useful, or can this set of data can be accepted or not? That is the question now. Now there is one thing we have to define, which is called as degree of freedom. So this degree of freedom is defined as n minus 1. N minus 1 means where n is the number of data. Here the number of data, set of data is 6. 1, 2, 3, 4, 5, 6. So 6 minus 1, that is 5 is the degree of freedom. Now if you observe the table, which is there in the statistical tables, if you observe critical values of chi-square as given. Critical values of chi-square as given. So for 5% significance level, you have to refer to point for significant level of 0.05. You have to read the value of chi-square for 0.5 for 5% significant level. If you read that for degree of freedom df5, for degree of freedom df5 for 0.05, the value of chi-square tabulated is 11.01 from the 07. 11.07 is the value of chi-square tabulated from the table. So you can refer the table directly. So this you can get from the table directly. So this is tabulated value. Now if you want to calculate the calculated value, so that is chi-square calculated, you have to use this formula. Sigma Oi minus Ei whole square divided by Ei. So here Oi is the observed value, Ei is the expected or estimated value. So there are 6 values, so you will be having some sigma means I is equal to 1 to 6. So we have to calculate the values for each data. So Oi is 103 here, 103 minus 106 whole square divided by estimate is 106. Like that you have to apply for all the 6. 143 minus 141 whole square divided by 141 plus 98 minus 93 whole square by 93 plus 42 minus 41 whole square by 41 plus 8 minus 14 whole square by 14 plus 6 minus 5 whole square by 5. So we have to add all the values, and that value itself, if you add all these values, that value itself is called as chi-square calculated. Now we have to compare this chi-square calculated with chi-square tabulated. So here chi-square tabulated is 11.07, chi-square calculated is 3.1779. So naturally this is less than this. So chi-square calculated is less than chi-square tabulated. That means you can accept the null hypothesis, or in other words, the observed and estimated values, they don't differ much at 5% significance level. She has asked at 5% significance level. That means 5% we are confident that we can accept those values. Suppose the same problem, if it is asked at 10% significance level, then we have to see in the table for 0.01. So 0.05 is for the 5% significance level. 0.1 is for 10% significance level. So 0.1 means it is from this table, you can take for 0.1 the value is 9.236. 9.236. 0.1 is 10%, okay? 9.236. So once again here, the tabulated value is 9.236. Calculated value is 3.1779. So here also calculated is less than is tabulated. Therefore, in this case also we can accept the hypothesis. Suppose if you take 90% significance level, that means if you are confident that 90% confidence level is there, that means these two can be accepted at 90% confidence level, then at 90% confidence level it becomes 0.9. It is for 0.9 it is 2.204. 2.204. This value becomes 2.204. You have to see for 0.9. For 0.9, for degree of freedom 5, it is 1.61. 1.61. 1.61. So now if you compare, chi-square tabulated is 1.61. Chi-square calculated is 3.1779. Now you can see that in this case it is reversed. That means this calculated is greater than tabulated. So in that case, we cannot accept the null hypothesis. We have to reject the null hypothesis. That means rejection means these data we cannot use. Suppose if you want 90% confidence level, if you have 10% confidence level, we can accept it. But if you want 90% confidence level, you cannot accept it. We have to reject the data. So as here, one thing you have to observe. As the confidence level increases, this chi-square tabulated level decreases. This one decreases. So if you are more confident to accept the data, then these values, tabulated values, they reduce. So they reduce. Then the possibility of rejection of the data is more. So it all depends on the percentage of confidence we have for the given data. So this chi-square test normally it is used to compare the observed values from the experiment and the expected or estimated values from the equations or the theory behind it. Then if you calculate both of them, this is of course from the experiments you get, this is calculated. Then if you want to compare how best we can accept the data or reject the data, we are going to use this chi-square test. Once again, that percentage of significance level has to be defined. As the significance level increases, there is a chance of rejection of the hypothesis. But if normally we take 5%, 10% significance level, and we are going to judge whether the data can be used further or not. So usually for lower values of significant level, for 1, 5 or 10%, normally we get exception of the null hypothesis. Null hypothesis means there is not much difference between the observed and estimated values. That is the meaning of null hypothesis. So this is a very important tool in comparing two sets of data, one experiment data, another one is theoretical data. So of course we have done earlier, we have computed coefficient of correlation between two sets of data x and y. Similar to that here, you can also find out the coefficient of correlation between these two sets of data. One you can treat one as x, another one as y. If the value of the correlation coefficient value is greater than 0.7 or 0.8, definitely it has a very good correlation. Now, of course, for this problem, you can also check the value of correlation coefficient. Definitely, you will get more than 0.7 or 0.8. That means the values are good. So, the more the value of correlation coefficient, we can accept the data. That is the meaning. Here also, if you get chi-square calculated value less than chi-square calculated value, then it is within the safer limits, we can accept the data. That is the meaning of it.